2007, number 2 for A, B, and B, C. They both had the same problem for number 2. The amount of water in a storage tank in gallons is modeled by a continuous function on the time interval from 0 to 7, where t is measured in hours. In this model, the rates are given as follows. The rate at which water enters the bank is F, and it's given by that. And that's this curve right here. They didn't say so, but it's calculator active, so you'll be able to see that. The rate at which water leaves the tank is this piecewise function, 250 and 2,000, and that's modeled here. Okay, I want to point out something that they very subtly said. The amount of water in a storage tank in gallons is modeled by a continuous function. And you might look at this and say, that's not a continuous function. There's a discontinuity there. Okay, wait a minute. They are giving you rates. So this is a graph of the rate of flow into and out of this tank. So the water's coming in, the water's going out. Okay, so this is in, and these two little pieces on the piecewise function are out. But the amount of water is a continuous function. So in other words, they gave me the derivatives. They gave me the rates. And if I wanted the area, I could still find it. I can still find the area. Let's ignore this curve. I can still find the area under this piecewise function, even though there's a hole in it. So I can have a discontinuous graph and still figure out the integral. That was just a little aside. It has very little to do with this problem, slightly, but not a huge amount. But I just wanted to point that out there. So you might see the word continuous and say, no, it's not. It actually is. The amount of water is continuous. The rate at which they flow into or out of is not. Well, the rate at which they flow out of is not. The rate at which it flows in is clearly continuous. Okay, so let's read the problem and go from there. The graphs of F and G, which intersect here, and they told us those values are shown in the figure above. Time t equals 0. The amount of water in the tank is 5,000 gallons. We don't need that right now. That will come in handy later. Let me go ahead and tell you, and as I go through this, I'll probably point out my mistakes in my thought process when I was working this out. When I worked this one out, I kind of almost forgot that, and I got to a separate part of the problem where I needed that, and I almost left it out. So sometimes they'll give you information at the beginning that you think you don't, you're like, oh, okay, maybe I don't need that, and later you do. So don't forget that it's there, and maybe underline it, highlight it, or you can't highlight it, but underline it or do whatever you need to do. Okay, so how many gallons of water enter the tank during the time interval from 0 to 7? Well, F is into and G is out of, so we're going to figure out how much flows in, not out. Round your answer to the nearest gallon, so no 3 decimal places on this part. So number 2, part A, here we go. If I want to know what flows in, then I just take the integral of my rate. So the integral of a rate gives me a quantity, and my quantity in this case is going to be gallons. So I'm going from 0 to 7 of F of t dt, and that's really all I'm going to do with that. So here goes. Let's grab a calculator. Let's figure this out. I'm going to clear out my functions from the last problem, and I'm going to type F. I'm not going to type G, not right now. G is piecewise, so I can't really type it all at once anyway. Sin of the square root of x. There we go. And so we have that. It is correct. Yeah, it's right. Double checking. Math 9. You know how to do this. There we go. 8,264. And they didn't say put the units, but let's do it because it's a good habit. If you have units, you may as well put them. Okay? Well, let's read part B and see what it says, and this is where things get a little tricky. Part A was pretty easy. Oh, by the way, the way they graded this one was the whole integral was a point, and the answer was a point, and the units were not. But again, good habit. So, part B, from 0 to 7, find the time intervals during which the amount of water in the tank is decreasing. All right, pause, think for a second. When the water is decreasing, the derivative is negative. The rate of flow is negative. Give a reason for each answer. So I'm going to walk you through my thought process when I did this one, and it is not the only way of thinking of it, but I actually created a new function. Do I have to do that? Is that the only way to do it? No, it's not. But here's what I thought. And I'm going to write my thought process. And they did say give a reason for each answer. So in my process of writing it down, I'm actually going to be giving my reasons. So let's see. If the water is decreasing, am I wording this correctly? Yeah, I'm wording it right. if the water is decreasing, I was really cautious about what I was saying there, but it's right. Then the rate of change, my handwriting is terrible right now, sorry, of water is negative. Okay, well, what's the rate of change of my water? So here's what I did, and they didn't do this on their answer key, but I said, I'm going to let W of t be the rate of change of the water. It is not the amount of water, it's the rate of change of the water. And the rate of change of the water is actually given to me, sort of, in pieces. I've got water flowing in, and I have water flowing out. That's a G, I'll put W. So I have water flowing in, I have water flowing out. So it's this, so in minus out, and there we go. Well, I want this to be negative. If this is gonna be negative, then I've got to think about what really makes this negative. So if I want that to be negative, then let's move this over. So f of t is going to be less than g of t. I look at that and I think, well, okay, I have f less than g. Wait a minute, I have a graph. So this is what I'm wanting, and I'm wanting to see where f is less than g. Well, this is f, and they never told me that, but clearly it matches that. And then clearly that's the piecewise part. So I need to know where f is less than g. Oh, okay, well, g is greater than f here, not here, here, not here. So I have two intervals, and if I can find my paper, those intervals are going to be here. The water is, I'm going to put amount of water. Amount of water is decreasing. On the intervals from 0 all the way to, well, where? Now we'll talk about whether it should be equal or not here, which actually they're not going to be too picky about that, I don't think. But from here to here, well, where is here? Well, you can find that on your calculator, but they told you, so don't waste your time. 1.617, 1.617, and from, well, here's the other one. From there, well, there is 3, and I know that because it lines up here, but I also know that because that's the breaking point of my piecewise function. So from 3 to here, which is 5.076, so 3 to 5.076. Okay, on their answer key, they put equal signs on all of those there, and I have never known them to be super picky about that, whether it's exactly equal there or not, but there you go. So let's see what they did. You get a point for the intervals, and you also get a point for your justification. And for me, from what I wrote, my justification was kind of like all this. So do you have to write all that? But no, you do need to demonstrate, though, that you know that f is less than g, and you do need to talk about why. So like the rate of change of the water is going to be negative because that's where it's decreasing. So they need to know that you know that. So how do you know that you're looking for where f is less than g? Well, because you're looking for where the rate of change of the water is decreasing, so it's negative. It's that kind of thing. So just talk through your logic. All right, here goes. Part C. And this is a tricky one. From 0 to 7, at what time t is the amount of water in the tank greatest? Pause, think. I'm looking for a maximum. Where do maximums occur? Maximums and minimums occur at the endpoints of an interval, 0, 7, where the derivative equals 0, and where the derivative doesn't exist. As we go through this one, I'm going to talk about some of my logic as I work through it and how I wasted just a little bit of time in what I was doing. And I'll kind of, excuse me, I'm at the table, and I'll demonstrate to you exactly what they did. And what I did wasn't wrong, but it was a waste of time. So here goes. Again, I'm going to write my logic as I do this, because they said justify your answer. So here goes. At what time t is the amount of water in the tank the greatest? To the nearest gallon, compute the amount of water at this time, and then justify your answer. So I'm definitely going to need a calculator for this one. The amount of water is a maximum at t equals 0, t equals 7, or where the rate of change is 0 or doesn't exist. And we'll explore that. Okay, so here's what I need to check. I'm going to go with this idea where the rate of change is 0 or it doesn't exist. So there's actually 3 points here, and I'm not going to write everything down. I am going to show you my scribbles that I did. This was when I worked it out. The amount of water in the tank was 0, 3, 7, or where the rate of change is 0. And here was my rate of change. So remember that function I defined earlier, like in minus out? And that equals 0. Well, if f minus g equals 0, then f equals g. And so here's where my logic went. I'm looking for where the f function equals the g function, and that happens here, and that happens here, okay? And here's why that was a slight waste of time. I am looking, and this was very subtle, and you could do it, but it might waste your time. So I'm going to spend a little bit of time explaining it now, just to kind of make you think through the logic of it. At this particular point, I have a negative flow of water. Okay, and here's why. This is out, this is in. Out is greater than in, so the amount of water is decreasing. Because the amount of water is decreasing here and then increasing here, yet part C asks me for a maximum, I don't even need to check that point. Okay? So if you're doing what I did and you tested 1.617, that's fantastic, but you're probably going to get a minimum, not a maximum. And similarly here, from 3 to 5.076, your outflow is more than your input, so you're going to have a negative flow leading to a positive flow, so therefore, you're going to have a minimum here, not a maximum. So we could waste our time finding those, but I'm not. So let's not. Now, I also need to consider what happens at t equals 3. Now, don't look at this and say, well, it doesn't exist there. Okay, and there's just two ways of thinking about this. And here was my way of thinking about it that was not necessarily wrong. What's the amount of water in the tank the greatest? Well, that occurs where the change is 0 or where the derivative doesn't exist. And technically they've graphed a rate of change, so they've graphed a derivative. So that's at 3, right? So I do need to check 3. And here was their logic. Their input was greater than their output, leading to a place, or leading to a time at 3 where their outflow was greater than their input. All right, so they have a lot coming in, they have a lot going out, so 3 is a potential maximum. Okay, so we need to check 3. So we're going to take 0, 3, and 7, and we're going to test them. So here's my time. I'm going to make a little chart out of this. And over here, I'm going to put water. Okay. Well, let's not think too hard. I got all complicated when I made mine and almost forgot the 5,000. And this goes back to what I told you earlier. See how I kind of squeezed it in here? And I'm telling you what I did because I want you to kind of walk through the thought process with me, not as if mine was the only way to think. But I also want you to avoid some of the little tiny things that can slip by you if you're not careful. So, how much water was in the tank at 0? 5,000. Okay, and there was a function that went along with it and all kinds of stuff, and I made it super complicated, but it's 5,000. All right, we got it. How much water is in the tank at 3? Well, I don't know, but it's 5,000 and then something, plus something or minus something, I don't know. Okay, I want to send some water into this tank for 3 seconds. How much water are we going to send in? We're going to send in F. How much water are we going to pump out? We're going to pump out G. Now, I can put the letter G. I'm actually not. Instead, I'm going to put 250 because that's what G is, at least for the first 3, right? So we're going to pump out 250. So this is F minus G, or at least the G part that's defined from 0 to 3. There we go. And we'll figure out what this is. I'm going to type it in the calculator in just a minute. Now, when I get to number 7, I'm going to have to figure out what happens from, I'm getting ahead of myself, but I'm going to have to figure out what happens from 3 to 7 and then add it to whatever I'm about to get right here. So 5,000 plus the integral from 0 to 3 of my function minus 250. That minus 250 is part of the integral. There we go. 5,126.591. By the way, they did say round to the nearest gallon, but right now I'm not. I choose not to. And I'm looking at the answer key, and I'm seeing if they rounded here. They did not round right here. They could have, but they didn't have to. Anyway, I digress. So I want to know what happens at 7. Well, if I want to know what happens at 7, why don't I take what I got from 0 to 3 and add it to whatever I'd get from 3 to 7. And what I get from 3 to 7 is f of t minus 2,000. I said 2,500. Almost said the wrong number. There we go. And we will subtract it. This is input minus output. So there we go. I'm actually going to take that last answer, and we'll just add that. That'll keep all those decimals there. And we're going to go from 3 to 7 of, whoops, hit the wrong button. It's wasted my time graphing this thing. I'm sorry. Let's go back here. Okay, as we time ourselves on this, try to keep each of these in about 15 minutes, generally. I know this one's run a little bit long, but I had a lot of explaining to do. Okay, let's make sure we've answered the question, which we actually haven't. We've kind of done some work, but haven't answered it. At what time t is the amount of water in the tank the greatest? Well, let's answer that. The amount is greatest. How about greatest? Greatest at t equals 3. The voice just cracked. With, and to the nearest gallon, so 5,127 gallons. And then they said justify your answer, and my justification, I believe, is here. So basically, they wanted to know, why did you pick these numbers? And how did you compute it? And that's built into the work that I showed. So here's what they were looking for. They wanted you to know that 3 was something that you looked for. Okay. They were looking for some of this work here. Your little integrands. These are called integrands, by the way. They were looking for this. They were also looking for this one, but it's all like one thing, so I'll just kind of make it one big red mark. So they were looking for that. They wanted to know this answer, they wanted to know this answer, and they wanted to know that.